This is a video on the integral test. The question states, determine if the series converges or diverges. We have the summation from n equals 0 to infinity of 1 over 4 plus n squared. So in order to use the integral test, I need to check two things. I need to make sure that the terms 1 over 4 plus n squared are bounded, and I also have to check that the sequence defined by 1 over 4 plus n squared is a decreasing sequence. So let's check bounded first. So I know that 1 over 4 plus n squared, if n is at least as big as 0, this is a positive number. And I also know that 1 over 4 plus n squared is a fraction whose denominator is at least as big as 4. So what we can say is that 1 over 4 plus n squared is greater than 0, and it's also less than 1 because the denominator is bigger than 1. We can say that these terms, 1 over 4 plus n squared, are bounded by 0 and 1. So now let's check for decreasing. I can think about the function 1 over 4 plus x squared and see if it's decreasing by taking a derivative and making sure that the derivative is negative. So let's do that. The derivative of 1 over 4 plus x squared is negative 2x over 1 plus x squared quantity squared. I use the chain rule for that. Notice the derivative of x squared is 2x. The derivative of something to the negative first power is negative that something to the negative second power. So now if x is bigger than 1, or if x is large, then negative 2x will be negative. The denominator is positive, so this whole fraction will be less than 0. And yes, we know that these terms are decreasing as n gets bigger and bigger. So now that we know that the terms are bounded and decreasing, I can apply the integral test. And that says that if we take the integral of this function, and if the integral converges, then the series also converges. If the integral diverges, then the series also diverges. So let's integrate, and I'm going to use x instead of n. I'm just a little more familiar with that. The integral from 1 to infinity, again, I can choose a bigger number than 1. All that matters is that when we get infinity, we have a nice well-defined number. Of dx over 4 plus x squared, the integral of dx over 4 plus x squared, that's an arctangent function. And you may or may not remember, that's 1/2 times the arctangent of x over 2. This is of the form dx over a squared plus x squared, and a is 2. So let's plug in. I get 1/2 times the arctangent of infinity minus 1/2 times the arctangent of 1 over 2. So now the arctangent of infinity, well, that is the angle such that the tangent of that angle is infinity. And that just happens to be pi over 2. So what we get is 1/2 times pi over 2 minus 1/2 times the arctangent of 1/2. And I don't really care what this number is. All I care about is that it's a number. Notice that all of these numbers are well defined, not infinity or anything weird like that. So we can say that the integral converges. And by the integral test, we can make our conclusion that the series converges, again, by the integral test. And I'm done with the problem.